Assalamu alaikum everyone. Welcome back to mathematics. We are solving A-level CI's paper, Pure Maths 3, paper code 9709, variant 32, May-June 2025, and we are doing question number 2. Question 2 says expand 6 minus x times 1 minus 2x to the power minus 3 over 2 in ascending powers of x up to and including the term in x square, simplifying the coefficients. Okay, so let's begin. First of all, we will just be taking our second part of the equation, that is 1 minus 2x to the power minus 3 over 2. 1 minus 2x to the power minus 3 over 2, because we have to apply binomial expansion on this. So what is the formula for the binomial expansion that we use in P3? That is 1 plus x to the power n is equals to 1 plus n times x plus n times n minus 1 over 2 factorial times x plus n times x square plus n times n minus 1 times n minus 2 over 3 factorial times x cube, and so on. Okay, the thing continues like this. Next term would be plus n times n minus 1 times n minus 2 times n minus 3 over 4 factorial times x cube. Okay, now what is this x and what is this n in this expression? The x is minus 2x along with the sign, and n is minus 3 over 2. Okay, so let's begin and expand this. Let's take it below. We have to expand this up to x square term. So it will be 1 plus n, that is minus 3 over 2, times x. X is minus 2x plus n times n minus 1 minus 3 over 2 times minus 3 over 2 minus 1 over 2 factorial and minus 2x to the power 2. And I guess so we should not be including any other term, because they are asking only for up to x square. So let's expand this. 1 minus, okay, you can it is recommended that you should be doing all of this calculation by a calculator, because there are chances of error. So just deal with x by yourself and multiply these in a calculator. So you'll end up getting plus 3x. Then again just put all of this in your calculator. So this will all give you plus 15 over 2 x square. That's it. Now we have to multiply this also with 6 minus x. So let's multiply that. We need x square term. Okay, okay, up to x square term. So we have to multiply all of it. So 6 and minus x multiplied with 1 plus 3x plus 15 over 2x square, and similarly minus x is also multiplied by 1 plus 3x plus 15 by 2x square. Okay, you can do them directly. I'm doing it like individually by writing this like this, so it's your choice how you wanna do this. This will give you 6 plus 18x plus 45x square, and the second term will give you minus x minus 3x square, and the next term we don't need because it will give you an x cube term. Now add them together, it will give you 6 plus 18x minus x means plus 17x, and 45 minus 3 means plus 42x square. So this is your 6 minus x times 1 plus 3x plus 15 over 2 x square equals 2. Okay, now what is okay, we just have to do this, we get this answer. Now part B, state the set of values of x for which the expansion is valid. Okay, for which values the expansion is valid depends on your x term. Okay, whatever your x term is, here the x term is actually minus 2x. So the expansion is on this binomial expansion is only valid when your x modulus is less than 1. Okay, in this particular case, what is your x? Your x is actually minus 2x. So your minus 2x modulus must be less than 1, and this implies that x is less than modulus x is less than 1 over 2. Anything that comes out of the modulus is positive, so when it comes out this 2, it is a positive 2. Second thing, what does it actually means? This actually means is that if you write it without the modulus, that x is greater than minus 1 over 2 and x is less than 1 over positive 1 over 2. This is one thing. Now what is the next thing? Next thing is this is enough for your answer, but just to make you understand it in a more better way, let's see what about these values. Okay, does your function remains valid on these values? Means does your function required expansion is converging or not on these values? So let's take 1 over 2. If you take 1 over 2 b equals to x, then what happens in the expansion? You get 1 minus 2 times 1 over 2 to the power minus 3 over 2, that gives you 1 minus 1 0, 1 minus 1 to the power minus 3 over 2. Okay, anything to the power 0 to the power something is not a problem, but when you get 1 minus 1 0 to the power negative power, it becomes 1 over 0 to the power 3 over 2, and anything like 0 to the power of anything will be 0, so that means 1 over 0, and that gives you undefined or infinity value. So that is why at positive 1 over 2 this function doesn't converges or is valid. This expansion is not valid. Now look at the negative 1 over 2. does your expansion stays valid for the negative 1 over 2? Let minus 1 over 2 be equals to x. So 1 minus 2 times minus 1 over 2 whole power minus 3 over 2 gives you 1 plus 1, 2 to the power minus 3 over 2. Although we have 2 to the power minus 3 over 2, and that gives you 1 over 2 to the power 3 over 2. Although your value is not like you are getting a valid value for it, well defined value, but still this is giving you this is giving you your x, that is, we already mentioned above that your x should be less than 1. So but here your x becomes equals to 1. So for x equals to 1, your series, your expansion may or may not converge. It could be converging or not converging, but here the problem is the power is minus 3 over 2. For negative fractional powers, it doesn't converge, it is not valid. For negative fractional powers, if x is equals to 1, the expansion is not valid or does not converge. Okay, so for this reason n is equals to minus 3 over 2. For negative fractional powers, the expansion does not converge. So this is the reason your at your x equals to minus 1 over 2, it will also be invalid. So this is not a part of your whole working, this is just for your understanding. The main thing was that you should know that your expansion is only valid for your x to be less than 1, x modulus. What is x? X is whatever is in place of your x, means 1 plus anything that the expression is your x, and that must be less than 1. So when that is less than 1, that means your x is less than 1 over 2 in this specific question. I hope you understand this. That's all about question number 2.